Okay, so good evening, guys. So welcome back. So we are going to continue with our Jenkins session. So today is Jenkins day 5 session, and the date is 5th of your October 2024, and the timing is evening 4 8 p.m. IST. So guys, today is a very important thing because today we are going to learn about something about the concept known as the build and packaging. So if you see in our day 4 session, in our last session, so we had covered certain things. Like what are the things we covered? We covered on exploring few of the things in our Jenkins UI, right? So whenever we create a freestyle project, we can clone the projects actually. We can clone means actually we can from a GitHub repository through your Jenkins UI freestyle project, right? You'll be able to clone the repository into your local Jenkins server and you can do further process. So if you see the diagram, if you see it in our last session, onto the day 4 session, we had we had this diagram, right? Like where what we did, right? As soon as the developer writes a code, right, he's going to push the code into the GitHub repository, right? So GitHub is a source code repository, right? Now the thing is that actually, right, so once it is done, so what happened, right? We already have a Jenkins server where we have written some kind of a free shell project or else a pipeline where we have written. So what that pipeline will do, it will try to pull the code. It will try to clone or it will try to fork the code, whatever is there in our Git repository. And once we clone it, what basically we have to do that we need to go and further we need to do some kind of a build. That means that you need to build or you need to create a package out of it. So why we do that? Because this code is a raw code, right? It could be written in Java, it could be written in .NET, it could be written in C or C++, right? This code is a raw code. You cannot give a direct code to this customer. You need to build a package out of it and you need to deploy that code into the end server. And finally, you have to make that application run. And you need to provide the steps to the customer on how to access your application. So you have to provide all the things actually. So it means that whenever you want to take a code and you want to install or deploy the code into our server, say for example, you want to install into some test environment or into UAT or into prod environment, you cannot directly take that code and deploy it actually. You have to create a package out of it and that package you need to deploy or install it. So now the thing is that the next step after what it does means you have to take this code and you have to set up a server where that server will be called as a build server. And every code, whatever the application which has been designed, right, it is a language specific. It means that if you're writing a code by using Java language, then there is a different way of doing a build and packaging. Similarly, if you are trying to use a .NET, you need to have a separate build server where it is going to take that .NET code and it's going to build and it's going to create a package out of it. So build and build or else the packaging is very, very important. So what we have to understand as part of today's session is that on our day 5 session, we need to understand about building and packaging the code actually. So the code could be anything. It could be Java, it could be .NET, it could be C#, it could be Python, it could be any language, right? So the DevOps engineer have to know like how to build a code out of it, how to build a package out of that code. So it means that he need to learn about this build server actually. So it is a language specific, as I said earlier. So here what happened, the developer, the DevOps engineer, he need not to really understand this programming language. If he knows, it is well and good, but there is no mandatory that he should know Java, he should know .NET, or he should know C or C++. That's not required. The only thing which you have to understand that what is a build server, how to set up an environment where I can take this code, raw code, and then I can create a binary or I can create a package out of it. So to do that, we have to understand, okay, this is a Java specific application. So I need to have some kind of a build tool, which we call as a Maven. So I need to have a Maven tool and appropriately I need to have some particular version where a Maven will be installed. It means that I will take one separate server. I will set up this server as a build server where I will install the Maven and I will set up some kind of environments. Say, for example, that Maven might need some kind of a variables, environment variable. I need to set up all those variables, environment variables in that server. So once we have set it up, then what happened, right? You need to call some Maven commands to build that application. But the thing is that when it comes to the build server, is it mandatory that the DevOps engineer has to learn about this build tool into very in detail? Is it really required? Yes, it is required. So always, whenever you try to compile or whenever try to create or build a Java applications, right? Then you need to understand how exactly the Maven works internally. What is a structure? What exactly Maven expects the the source code structure of the Java, right? What are the configuration files of the Maven, right? How exactly Maven does some kind of how the Maven does, or else how I can say that how the Maven can download any kind of a repository, external repositories or the libraries, right? How you can use plugins with the Maven, because everything, whatever you do, any kind of an operation with the Maven, it always involves some kind of a plugin. So what are those plugins and how exactly Maven internal works? We need to have some in-depth knowledge on that particular build too. So no doubt, we are not really worried about the language with which the application is written. I'm not really worried. It could be Java, it could be .NET, it could be C++, or Node.js, or any language the developer can use to develop an application. I'm only worried about the build server. It means that I'm only worried about the tool which has been involved in doing a or creating a package out of it. So in this session, what we'll be learning is we have to understand about the basics, understanding about what exactly build and or packaging is all about. So this is not, if you ask me, both are one of the same. If you say build and packaging, both are one of the same, right? It compiles it. So what the build or packaging means that it will take a raw code. It will take a raw code. It means that what is raw code? It will compile it, and you are going to get some kind of a binary sort of it, right? And then with that binaries, you will add some more other external libraries to create a package out of it. This is what we call it as a build process. So it means that actually there has to be some kind of a compiler where the compiler will create a binary and it's going to add some more external libraries, and finally a package would be there. And this package, whatever you are getting a package, right? It could be a language specific. Say for example, if I am talking about Java, so whatever the package you're building, it could be a jar package, or it could be a .var package or .var extension, or it could be .ar. So take all such files, you can create a zip file out of it actually, or you can create a compressed zip file, you can create it actually. So this will be something like an installable build actually. It means that you can take a package and you can directly go and deploy into the server, right? So what we have to learn that, guys, we have to understand about how exactly, so to do all these operations, we have, in case of Java, we have some tool known as a Maven. Before Maven, we had some other tool which we call the Ant tool. Later, Ant was replaced with Maven, and now and till today also, like in across the organization, they're using the Maven as a build tool. So apart from Maven and all, right, we have many other tools, like we have a Gradle tool is there. Many such tools are available. So we can use any of these tools, and you can create, you can use for doing a build and packaging, right? So now the thing is that actually, right, if you go in the organization, most of the organization, what I see, like 70, almost like 80% of the companies, they're building all the codes in a Java only, right? But nowadays, what I see that actually most of the companies have started working on Python. It means that they have started building their web application through Python, the front end with the React JS, right, or Angular JS. These are some of the languages which are heavily used, right? And for your backend, they're using your Python or your Go language to build or to design the application, right? So they're using a different languages. So for front end, they're using a different language to develop it, and for the backend, they're using a different language, right? And every language, guys, whenever we work on any language, right? You will take any language, you take any programming language. Always each has its own dependencies. So what do we mean dependency means? Whenever you are using any kind of a programming language, say for example, you are using a Java language. Java, it needs many of the external repositories. It needs many of the external repositories or external dependency it needs. So for example, like whenever you want to build any Spring Boot web application, right? We use a Java and we need to download. Java is required. Java anyway is there, but you need to download the. You need to even download the Spring Boot framework, right? Similarly, for example, you can use the Python to build a web application, but Python needs many other dependencies. Like for example, it needs a Django framework, right? It needs a Django framework to make sure that you can build an app like that. Every language, guys, it has its own dependencies, or right, it has its own dependence. It means that you need to somehow, before the developer starts doing work, what he will do that he is going to install the Java in his machine, as well as he will see that okay, I'll be using a Spring Boot, I'll be using Hibernate. So whatever the dependencies are there, I have to already I should install it and I have to make it ready. So to install or to download all kind of dependencies and install it, actually, we have some tools are available. The tools are available. So every language, like it could be Java, it could be Python, it could be Node.js. Every language has its own tool, which will resolve the dependency. So it means that you need not to really worry. It means that the developer has to need not to really worry. He can use the tool and he can download all kind of a dependencies, whatever it is required when he is developing the code actually, right? So it means that whenever a developer is working, he should understand on which language he is developing it, plus what are all the different other libraries or the repos he might required while doing it, and how to download and how to install it, and how to keep all the environment ready before he start writing the code or before he proceed with writing the application, right? He need to set up the whole environment, or we call it the stack actually. So this what happened, right? This the developer is aware of actually. He will be aware of and he will do all the setup actually, right? So guys, whenever you take the packaging, if you're taking a build or packaging, you take a build and packaging, it is language specific. That is one thing. And there are broadly can say that there are two categories of no, building a package. It means that actually that if you see it, let me draw the diagram, right? So there are two ways of packaging is there broadly. If you see, there are two way of packaging. So what are those two ways? So it means that suppose you use certain programming language where you can run the program directly from the code itself, right? It means that you can run from the code. So you can run directly from the code. Run directly from the code. It means that you need to really compile and you need not to really create a package out of it. You can actually directly run the code from the from the code itself actually. So so what are those languages which are there, or what are the programming languages which are there which can directly run from code? You need to even really involved in doing a lot of build processing. It is not required. So one among is nothing but your Python, right? Python is the one actually when you are using a Python, you can actually directly run the code using with the Python itself actually. So it will allow it to run it. You need not to really compile and do it everything. You can directly run the code from Python. Similarly, what happened? You are having something like a PHP. So PHP is also one of the language where it is something like an interpreted language. You need not to really compile the code. You can directly run the code right from the PHP program. So same thing, you have a Node.js actually. So using a Node.js, also you can directly run a program. You need not to really build that application. It means that you need not to really compile that application. You can directly run that application directly from the code itself. Right. But there are many other languages are there where you need to do, you need to build, or you need to create a package, or you need to create a binary out of it. After you create a binary, then only with the help of some kind of a runtime environment, you can run that application. So the second category what we have is nothing but run the application from the binaries, right? Run the application from binaries, right? Say for example, you have a Java language, right? For the Java language, yes, of course, when you are developing any application through Java language, you have to build it actually. Without a build, you cannot simply run the code. You cannot run the code. And you cannot run the program directly from the code. You need to create a binary, or you have to build out of it, and then what are the output you get, right? With that output, or with that execution format, you can run that application, right? Now, guys, whenever you have
Sir,
a
just sorry to interrupt. Sir, build means you mean like .exe format like this,
yes,
or
.exe, yeah,
yeah.
.exe, or
Yeah.
installer format,
Yes.
or
Okay. Okay.
like that.
Okay. You are
Yeah,
meaning
jar
that.
format, whatever the format. So
Okay. Got
even that format is also a language specific. Say for example, you have a Java, right? You can Java, you can build majorly you can build some three different execution formats you can build. What are those execution format? There are three execution formats you can build like this. So what are those? One is nothing but the jar, and other is nothing but the var, and other is nothing but the er, right? So you can create a jar file, you can create a var file, wr var, or you can even create a er file. Right. So for example, if an organization is building an application where the application might be some too simple program or too simple Java file, it could be there. Then what the developer will do that they're going to create a jar file for out of it, and then they can run a jar file directly. They can run a jar file like that. So it means that not many files, or not many files, only one or two or maximum few files, where they will try to code it everything, and then they can compile it, and they can create a jar out of it. Actually, jar means Java archive. It's a collection of some few class files actually, or few executive files. Similarly, what happened? You can build a var file, WR var file. So, say for example, if you're having an Apache Tomcat, so Apache Tomcat, whenever you're deploying any Java-based application through Apache Tomcat server, then that file format, it should be a var extension, .var extension. Similarly, you have something like EAR format actually. EAR format basically, say for example, if you have a Red Hat JBoss server, EAP server, or EWS server, then you need a file to have an extension as a EAR. So using your build tool, okay, you can tell to the build tool either you need a jar, var, or ER. Accordingly, what happened? Your build tool, that's a MAM build tool, it's going to give the output of that binary. So it means that you have to just give some inputs to your MAM build tool saying that, hey, this is a Java program, but at the end I need to get a var file, .var file as an extension. It will give you, it will compile, and it will build a package and it will give you with a var extension. Same thing with the ER, and same with the jar. So it depends upon our requirement at the end, like which format I need, so that I can use that format for running my application. Right. So for the var file, it's not like that it can run directly like that, guys. So it needs it has its own configuration files, right? Configuration.xml files will be there, and many of the other servlet files will be there where the var it's required. So that Apache Tomcat server, right, application server, it will give that environment where the var file can execute. Same thing with the ER. ER also what happened, right? It needs some kind of a environment where it can this ER file can get executed. Same with a jar file. Jar file, what it needs, it basically just need a Java runtime. That's all. So wherever Java is installed, you can run that jar file. That's all. But here, whereas ER and WR, it needs some other special things it needs. It means that this can be hosted, or it can be run under some application server only. right? Apart from the runtime environment, it needs many other different things, so that with that help of that, like it will be able to execute. Actually. Clear? Same thing, guys. So it's with the Java. Same thing, like you have many other languages. Say, for example, you have Microsoft .NET .NET, right? .NET also, what happened that you cannot directly run that application, right? You need to build out of it. You need to create a binary out of it. So basically, what happened? You have two executable formats actually. Two execution formats are there. One is nothing but you can build a DLL out of it, dynamic linking library. DLL you can build, and the next is that you can build an .exe. So these are the two execution formats you can able to build out from the .NET application. So DLL and the exe format, executable formats, right? So similarly, you have some languages like other languages like C, C++, whatever we have, right? C or C++, right? So to the C or C++, whenever you're building a C or C++ program, you will be creating, you'll get a major, you'll get two outputs actually. One is nothing about your assembler output, A dot out, we say, A dot out, assembler output, and the other is your ELF format. Other is nothing but ELF format. So these are the two execution domain or the format you can actually create when you are compiling or when you're building C or C++. Okay. So what is required actually that whenever you are building an application through Java or .NET or many other higher level language programs are there, then what is happening that this requires some kind of a build steps. It means that you need to build out of, you need to build it actually. So it requires a steps to build it actually, steps to build it, right? Steps to build it. It requires a steps, right? So to get a binary, or you need to get a binary means you need to first have a steps to how to build it. Right. So what this will do basically when you're building it, what it does that it will convert the code, whatever the Java, .NET, whatever is there, it will convert the code into the binary. It will convert the code into the binary or into the execution. Right. It will convert the code into the binary. Convert the, sorry. Right. So most of the most of the software languages, particularly high level languages like Java, .NET, C, C++, right? It always requires the dependencies. It always requires the dependencies. Say, for example, whenever, as I said, right, whenever you want to build the Java Spring Boot, actually, Spring Framework, Spring Boot application, it needs a Java framework. It needs a Java or else Spring Framework. It needs. So what you can do that actually that if you go to the Google and just say Spring Framework, right? So see, you can see that spring.io. So from this, what happened? You can download all kind of a dependency, whatever you need, right? You can download everything from this Spring framework, right? So what we say basically, guys, so this framework, this this Spring framework is a dependency, we say, is a dependency. Or we call it as a repository. Usually we call this as a repository. We call this as a repository. So we need to download that repositories actually, right? So that's what, whenever the developer is working on this Spring Spring Boot application, he will download all this Spring Boot dependency or the libraries. He will install it based on his requirements, and then he'll start working on it, right? Clear, guys? Now, for example, if I want to give an example, a real-time example of about what exactly dependency or repo or everything, right? You can even call it a repository, or you can call it as a dependency, or else you can even call it as a library also. So it means that you need some external libraries to do it. Say, for example, you have a Java program, and from your Java program, you have to, or you need to send the SMS actually, send the SMS messages. How are you going to do that? Suppose a Java developer is writing a code, and after he writes a code, he has to send an SMS actually through his code itself actually. So there are a lot of codes available. There are a lot of codes which are already available actually, right? So where what happened that he can use that part of code in his program, so that he need to rewrite that code again. It means that whenever you want to send any SMS through your Java, there is already a library or there is already a repository is there. You can use that repository, and with the help of that repository, you can send the SMS through your code itself. So you need to redesign everything again. You need to rewrite the whole code again for sending the SMS. Already a library is there. So that is nothing but the dependencies. So how you are going to do that? So you can just go to the Google and just say send SMS Java, right? And if you come over here, can you see this is a site actually? If you click on this, so you could see that actually there is a code which has been written over there actually. So he has given it. So this is the code. This is the XML file, and this is the code. And you could see that actually that he is using this package, okay, Twilio SMS controller, and he's importing all the dependencies. It means that he's importing all these libraries actually. And then like through that, what happened, right? He's trying to call message.creator and to the new which phone number he want to send the message and what's the message you have to send. All these details the code is already available. So what the developer can do, that the Java developer, he can directly copy this whole code. He can directly copy his whole code, and he can make use of this code actually in his code in his Java program. So I need not to rewrite it everything. Already it is there. It means that whenever I want to make use of that particular functionality of sending an SMS, I have to basically use this some like a dependency package. I need to use it. So you could see that TVO SMS control is there, right? This you have to use once you're using that package, and you can import all kind of those functions whatever you need, and you can make use of that functions in your program. So this is how you have to use it. It means that it is so simple that you can use this code, already existing code into it. So this is what the link I'll be giving you. So this is how they will use it actually. Same thing, say for example, like suppose I'm writing a Python code, and through the Python code, I want to send an SMS. So it's the same process. You have to go here, and what you have to do that you have to go and you have to just say send a SMS Python, right? And if you do it, I think same site is there actually. So if you open this site, you could see that they have given a code of how to send an SMS. So this is the code. He is saying that import OS. After that, he's saying from TBO trust import client. And then you could see that actually he is sending a message actually, right? So here what happened again, Python developer, he need not to write the whole code again. He need not to reinvent it. He can make use of the existing code. So how we can do it actually, you need to download all these dependencies. You need to download that dependency and make use of the dependencies in your code, right? So this is the link for your sending an SMS to through your, I mean, send SMS if it is a Python code. Clear, right, sir? So now what is happening that if you see this diagram, that you are having a build server. In this build server, you need to configure in such a way that actually that you are using some build tool. Say, for example, I'm using a Maven build tool. Maven build tool should even resolve all kind of dependencies, right? So how we will know that actually that how it can resolve all those dependencies, because there are some configuration files are there where in that configuration files, say for example in case of a Maven, there are two important files are there. One is a settings.xml file and other is a pom.xml file. So these are the two files which we will be doing it. So whichever appropriate dependency whatever we require, right, we have to go and we have to add in into that into those files actually, right? So we will soon come across with the what exactly the pom.xml files and settings.xml file is there, and a few other files, configuration files are there where we'll be learning it, and we will understand, okay, those configuration file will issue all kind of a dependency. It means that whatever the dependent package is required, it'll be downloaded by your Maven build tool itself, right? So that's the reason learning or understanding about any of the build tool is very, very important. And one more important things, guys, actually, if you go for an interview, in some of the interview, they can ask you a lot in the build server itself, because they will verify how much that person has worked. Say, for example, if you say that you have worked on Maven build tool, or you have worked on deploying or managing everything, all Java-based projects. So obviously, what happened, right? He will know that you have worked on Maven build tool also, right? Then what happened? He will start asking you how well you are, how much you are aware of Maven. You will say that, yeah, I know everything. Then he will start drilling you a lot in Maven. So if you answer each and every question in onto that builds or whatever he asks, right, then it is very good. He will get a lot of confidence on you. So that is always that whenever you showcase that you know something on CI/CD, right? So they'll be more interested to know about like how you are doing any kind of a builds actually. It means that what are the dependencies you are resolving it, what are the real-time issue which you have faced when you are doing a build and deployment, and what issue you faced in Maven build tool or Gradle build tool, like that. They will ask, or else they'll ask you how you're going to do a build and deploy of your Node.js or Python. Can you tell me the steps? They will say. So you have to answer it very well, those things and all. That's very important actually. Clear? So now, so as part of our course, guys, we have to learn about the Maven. So I will be in our next session, like from Monday onwards, what I will do that I will be taking around 2 to 3 sessions only on Maven itself, so that we will learn in detail about how exactly the Maven works and what is the structure of your Maven, how the Maven look like. It means that basically we'll be learning about the architecture of the Maven build tool itself. And then like one and how to install the Maven. You can install the Maven in Windows or Linux or Mac OS. It is a platform independent. We can install the Maven build tool anywhere. And then like we need to understand about all the configuration files. Whatever once you install it, right, you need to immediately go into the configuration files and understand. And finally, you have to understand what are the commands which are involved with that Maven build tool, and what are the goals. What are the different goals it provides it, and there are many other things are there which we have to understand about the Maven build tool. So slowly, one by one, we have to understand, because this is a stepping stone. So when we start learning or when we start working on Jenkins, we need to first understand about the build process. And for understanding the build process, we should be very good in any one of the build tool. So if you say that's a whole life, all my life, that's 5 6 years, whatever the experience you put, you say that almost all my experience in my DevOps, I only worked on Maven build tool only. Yeah, you can even tell that also. No problem. There's no issue with that. Oh, okay, you might it means that you'll be involved throughout your life. You are only involved in doing all kind of a build of all only Java based application. Yes, you can tell. But yeah, but what happened, like always you try to show some differences, saying that I was involved in Java, I was involved in build and deploying the Python, Node.js, many of the different application also you have to tell like that, so that they will get a confidence on you. That's all. Only you say only one thing means okay, they'll say okay, but it doesn't look good actually. You have to say 2 3 different languages I've used, where I have built and deployed the Java, I have built and deployed, even sometime I did a build and deploy of the C or C++ application also, Java based application, Node.js, right? So many other languages are there, right? We can tell that whenever if it required, but you should be confident of when they ask you about the build process and all, you should be able to tell it very clearly how you're doing a build and deploying when it comes to Python or when it comes to Node.js. And whether you should literally know like how you are setting up the build server, what are the what are the package you install, and what are the commands you are using. Even that also you have to tell it very clearly in the interview time. Right? Okay, good. Fine, guys. Okay. Now the thing is that, guys, actually, that whenever this is something like it's a build and package out of it, you're creating it actually. But as I said earlier, right, whenever you're building any package, actually, what is happening that every code or every language, it had its own dependency actually. It had its own dependency. Dependency is something like a model or the library or the repo we say. Now the thing is that actually that whenever you are having dependencies, right, how you are resolving the dependencies. It means that suppose Java, it needs a Spring Boot framework. How Java is to resolve, you know, in the Spring Boot frame. Is there any external tool is there through which the Java can download all its dependency and install it? Yes, there are some external tools are there. So we need to understand about what are those tools or the management tools which were needed when you are developing, no, when you are developing or when you're working on a particular language, right? So 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 you know that like whenever you have a code, actually, this is your code actually. This is a code. So whenever it could be Java, it could be .NET, it could be Node, just anything. So it could be anything, right? So always there is a dependency for this. Always there's a dependency. So whenever it needs some dependencies, always there was a dependency, right? Dependencies, right? So what is a dependency means? It means that it is a kind of a reusable code. It means that it could be a reusable model or reusable libraries actually. It could be a reusable libraries. Now, many times what happened, you can get all the many of the time what happened, right? What are the reusable libraries you need or the models are need, right? You can directly download from the net itself. It means that all those libraries are open source. Many of the libraries are open source, which are available freely. You can download from the net and you can install it actually. So for example, in case of a Java sending an SMS or Python coding sending SMS, right? You can use this code actually. You can use this, you can use this Tivlio SMS controller, right? You can use this library or you can import this model and we can make use of it that in your code actually, right? So those are never open source. It's a freely available, right? It has freely available. But sometime what happened, right? In the organization, what happened, right? The developer himself have to write a library. He has to write up. There are many projects are there which are very close project where what happened, right? It will be kind of an enterprise application which the developers will be writing. So for that, what happened, right? They don't want to use any kind of open source code which is available freely. So what they do many times in an organization, they will internally the developer will develop the code actually. It means that the all the dependencies also will be internally developed by the developer only. So internally, so what we say that actually that we say that internally the developer will develop the libraries. In many organizations, it happens. Say, for example, in Walmart, right? The developer write their own libraries, actually. Same with Amazon. They will not depend upon the external library or they will not depend upon the open source. They will be writing their own libraries, right? So whenever the code needs, right, based on the requirement, it can either download and use the open source or else internally what are the developer is developed, right? Those libraries or those models can also be used by your code. So guys, what happened now to manage this code, to effectively manage this code, right? Every code, it has a structure actually. It has a structure. So it has a management, or it has a structure. So how to manage it? So how do you do the management of all these things? How do you do a management of all these things? We say that for any kind of a dependency, always the dependency is right. The dependency is something like it's a metadata. The dependency is not it's a metadata. Every dependency is a metadata. So that metadata means what happened, right? In turn, the metadata will, what it has, some two important information. One is nothing but the name of that metadata, and other is a version. What is a version we are using it. I'll come across with this later. Right now, you understand that whenever you are resolving any dependencies, it needs some kind of information. You will get the information through a metadata. So metadata is nothing but the name of the dependency and what is the version we are using, right? So this together we call it as a metadata. Say for example, I'm just giving a very high level example like this. Say for example, uh, for the Java, right? For the Java, you need a Maven build tool. Maven build tool is required. Maven build tool, it always sees a file by name pom.xml file. Now this pom.xml file has, if you see the structure of the pom.xml file, I will be showing it later, or else I'll be showing in the next class. Okay, it has something like a group ID, artifact ID, version. This group ID, artifact ID, group ID, these are certain kinds of a metadata. These are certain kinds of a metadata like this. So it means that every tool, right, whenever doing it actually, how it understands means with the help of some kind of a metadata. It means that how exact dependencies and all will be managed by, it is managed by certain things known as a metadata. So we will come across with this metadata after some time. So it has some name and it has a version involved with that actually, right? So that is all about your management, right? So it has a metadata. And what happened apart from this, actually, what happened, right? Every language, it has its own internal tool. As I said, right, it has its own internal tool which will resolve the dependency, right? For the Java, if it requires the Spring Boot framework, there is some internal tool is there where the Java will use to install all those dependencies. Similarly, for example, you have a Python. For Python, it needs certain kind of an external tool where it will resolve all kind of dependencies. So what are those tools or some of the tools, to name a few? Right, to name a few, you have something known as the tools. Right, we have something as a tools actually like this. What are those tools? Why I'm saying all these things, because it is better for us to understand, guys, because if we are learning anything in a broader way, like we should understand all these basics actually, right? For example, you have a Python. Assume that you have a Python. You are writing a developing application to the Python, and Python needs a lot of dependency. It means that it needs to install a lot of libraries or modules. Then, is there any tool through which the Python can install it? Yes, there's a tool which we call as a pip tool is there. Pip is a tool which internally Python uses to resolve any kind of a dependencies. So with the help of a pip, you can install any kind of a dependency library or the module. So this is one example like this. Similarly, what happened, right? You have something known as a Java, right? Suppose you have a Java language. So Java want to resolve all kind of a dependencies. How Java can resolve all dependencies? If suppose if it want to install the Spring framework, it want to install some kind of Hibernate, some other dependencies. Then in that case, what happens? There is a tool by name Maven, and there is a tool by name Gradle. So it uses this to resolve all kind of dependencies, right? Maven build tool, or just say Maven, or you can use Gradle, Gradle, right? Right. Similarly, what happened, right? You have many other language programs. Say, for example, I have something like a JavaScript. You have something like a JavaScript, or we call it Node.js. You can even have a Node.js. So, but JavaScript or Node.js, requires some dependency. While when you're developing, right, the front-end application by using JavaScript or Node.js, it might require some dependencies. So are there any tools it uses? Yes, there is a tool. So what are those tools? We call, there are two tools are there. One is an NPM, other is a YARN, 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 right? So the tools are NPM, right, and YARN, YARN. What is it? YARN, 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 right? So it uses this tool, YARN or NPM, to resolve all kind of a dependency. Is it fine? Suppose you want developing a .NET based application. You have a .NET, right? You have a .NET. So this is a .NET language. And suppose if the .NET needs some kind of a dependencies, so how it can resolve the dependencies? There is a tool, external tool, which they use it, which you call a NuGet. Nugget, we say Nuggt, Nugget. Using that, what happened, right? It will try to download all dependencies. If your .NET application needs any external libraries, it can install through Nugget or NuGet, we say Nuggt, right? So now, as part of this diagram, guys, what we have to understand, that we need to understand about how to set up this build server, how to even have these tools, whatever you're saying, Rajesh, right? How to have these tools, and then like how you can make sure that all the dependencies also can be downloaded and installed it. Right? Means that before the builds are happening, or during the build process only, what happened, it will try to download. If it is not there in your local repository, say for example, like whenever it want to download it, so there is something like a local repo and there's something like a remote repo. So now what these tools will do, right? These tools, all this pip, maven, gradle, or npm, or yarn, or NuGet, right? All these tools, external tools, what it will do, right? It will try to check in your local repository if it is there or not. If it is there, then what happened? Directly it will try to link from the local repositories. If it is not there, then what happened? It will try to go and download from the remote repository. A remote repository is something like outside your network, right? In the internet, those repositories are available. So using those repository, it can download all kind of dependencies. How it downloads, again, in turn, what happened? This tools uses some plugin to download it, right? So it means that, Rajesh, you need a plugin. Okay, firstly you need a tool. Firstly, you need to have a Java language. Okay, right? I need to have a Maven tool installed. Fine. You need to write some configuration files, something like a pom.xml file where you'll be writing all dependency. Yes. You'll also be mentioning some kind of a plugins or dependency which is required you to download. Yes. So during the build process, when you're building, when you're calling a Maven build tool to build a process to create a package out of it, at that time, what happened? It's going to check, okay, your application, it requires, okay, it requires some kind of Spring Boot framework. Okay, Spring Boot framework is not there in my local repository. Then you download it. It will say download and install it and keep a copy of that in your local repository, so that the next time again when you try to build it, no build the Spring Boot application, right, it doesn't really download again. It will make use of the existing in your local repository. So this concept of managing the local repo and a centralized repo, or else you call it remote repo, how it manages everything, these are very, very interesting things which you have to understand. And some of the questions that will come from that area also, where it will say that, okay, how to resolve, or suppose that your application needs some kind of dependencies, but you don't want to really go to the internet and download it. You need to somehow manage everything through a local repository. So can you build your own local repository within your organization? It's something like a private repo. How you're going to do that? How it will resolve it? Have you ever come across with certain things, such things they'll ask in an interview? So to say yes, most of the time, some of the organization doesn't really want to download anything from the outside, right? Right. Many of the critical applications, right? They don't want to really connect to the outside world, right? And they don't want to download. So they will keep all the local copy in their local repository, or within inside a company, they will create one server where they will manage everything local repository. They will set up everything. So whenever any developer, like Java developer, he needs any kind of dependencies for his requirement now, he will directly connect to his local repository within his organization, and he will download everything, and he will try and he will make use of it. So that is something like where certain organizations do that also. They will manage their own local repository. They don't have something remote or central. They don't have that remote repository, right? So that is also there. Like, okay. So now, as I said, right, like to build it actually, to build any kind of a Java-based application, you have a Maven tool. Before the Maven, the Ant tool was there. Ant tool was developed by a foundation, or the Apache Free Software Foundation. So that was an organization which they build an Ant tool actually. Why they build an Ant tool? Because that see, if you are compiling, if you are working on only one file or two Java program or two Java files, and you are compiling and you are trying to run application, that is fine. You don't need any kind of a build tool. Suppose, for example, there are hundreds of applications are being written by a lot of developers in organization for the same project. It's not one file, right? There could be hundreds of files, Java program which should be written, right? You need to manage a lot of files, and you need to compile whole all the files you need to compile. It means that you need to take all the 100 Java files and you need to compile and you need to create a package out of it, right? So doing it manually will become very, very tedious task. You cannot do it manually. You cannot run a Java command to always compile, and then you do a link and then you try to run it. You cannot do that. It's very, very difficult. Hence, what happened? The Apache Free Software Foundation, they came up with this Ant tool actually. And what the Ant tool will do, Ant tool will make the developer's life easy, right? There's some pre-requirement that whenever using Ant tool, right, it follows something like a, you need to have something like a build.xml file. I will discuss about this tomorrow. Build.xml file is there. So what the Ant tool will do, Ant tool will always look into the build.xml file and then appropriately try to create a package of it. But the point here with the Ant is that actually that Ant tool, it has some problem actually. It cannot really resolve a lot of dependency issues. It cannot really resolve it. Hence, what happened, right? What the same foundation they did, right? Apache Free Software Foundation, they came with their other tool as a Maven tool. Maven tool is better than the Ant tool, and then like Maven can resolve all kind of dependencies. And it can build any complex project, Java-based projects, right? Whatever you need, right? The external libraries and all, it can happily download everything. So it will resolve a lot of problems. Whatever the Java developer needs, right? Most of the problems, everything will be solved by the Maven tool. That's the reason Maven tool is very, very famous actually. So one difference between Ant and Maven is that you have to just say that Maven can resolve any kind of a dependencies, but Ant cannot really resolve. So that was a major drawback in Ant. But still, I see that some organizations, very few organizations are still using Ant. For certain requirement they use Ant, but almost 99% of the companies they've already been using Maven for a very long time. Is it fine, guys? So as part of our learning in Jenkins, guys, as I said earlier, we need to learn about this Maven very well. And that is what we'll be seeing in our next 2 to 3 sessions, how we will be learning about the Maven tool. Is it
Rajesh,
fine?
what is plugin you explained before? Can you please
Yes.
explain that one?
You will come across, sir, when I'm explaining about the Maven in detail, right? I have to explain about the dependency section. In the dependency sections, you need to like mention about what are the dependencies are there, and then like you need a lot of external plugins also. All these plugins also, you have one more section, or the plugin section is there. So you need
Mm.
to really explain the architecture of your Maven build tool, and then like whenever the developer, Java developer, when they are writing a Java code, right, they need to follow a structure actually. Simply, they cannot write a code anywhere like that. They need to follow a structure. It means that they need to have a folder by name SRC, something like this. They need
Mm.
to have an SRC folder like this. And they need to have a folder known as a test folder. Under SRC folder, right, they need to write the main.py or main.java like this. Right. Under the test also, they need to write something like a test.java. Something they have to follow a standard procedure way, a kind of a directory structure they have to follow it. Why they have to follow it? Because a Maven can only understand the structure. That's all. If the structure is not there, if there is no file, if there is no structure like that, Maven cannot understand anything. Maven cannot do build if there's no structure. So what happened now? When the developers are working on a project, right, they need to understand the convention. It means that how I have to develop or what should be my directory structure, where and all files should be there in which and all path. He should be aware of it. You cannot simply write a code anywhere and start calling your Maven build tool. No, it will not work like that. There is a process is that you have to follow that process. So that is what we will be learning in our upcoming session, like how Maven exactly do the build activity, what are its important configuration files, what are it needs actually it needed, and finally we have to even see a small Java program, and we need to see that how it can build those Java program with the help of the Maven goals. So when you use a Maven, you need to pass some MVN command we have to use, and you have to pass some goals, you need to pass some parameters, and all. Like then later what happened, right? You need to we will be seeing in our upcoming session, right? Suppose I have a Jenkins server, I have to create a separate build server, and this build server where I'll be installing Maven and all, right? And then how you integrate this Maven build tool with your Jenkins server. So now whenever the Jenkins downloads a code from the Git, this code will be given as an input to your build server. And what the build server will do, it will take this code and it will try to call a Maven build command. So Maven build, what will do that? It will try to build this application. So during the build process only, the Maven will understand, okay, to compile the code or to build this code, it needs some kind of a dependencies, or it will try to download all dependencies. Okay, it will do it. And then if it requires any plugin to be installed and downloaded, it will try to download that and install it. And finally, what happened, right? It's going to build a package out of it. And you will take that package and you're going to verify, test it, and finally you're going to deploy it. So that's how it is actually. And we need to understand about the output also, what kind of output you are getting after the build is completed, and how you use that output, and how you're going to do a deployment. What are the other factors you have to consider while doing a build and deploy? You have to even understand that also. Will be discussing elaborately when we come across with this Maven build. Right? Now the thing is that let us see, for example, as I said earlier, like here, in case of here, you have a Python code or you have a Python installed in your system, and I need to install the dependencies by using a pip. Can we see a small example on how to install some kind of a dependency to the Python? Say, for example, in my system. So let me do one thing. Let me log into my uh, AWS console. I think I have destroyed my Jenkins server. The last session, day for yesterday, right? When I took the last, I think it is not there. I think I have to again do a build actually. Or let me see. I think it's not there. Anyway, I don't need that server. I will build it again tomorrow when I start with the next session, right? I need to have a Jenkins server. Now, right now, I don't have Jenkins server. I have to do again build, and I have to again do an installation, and then I have to do all the setup. I will do that later. No worries. So now what I will do, guys, actually, like basically, I will try to launch one server, launch a machine, and let me give some name, like something dummy server, because I want to do some experiment. That's all. So I'll choose Ubuntu. Okay, Ubuntu, and come down. I will go with the latest 24.04. Okay, T2.micro is fine for me. I will go with the key. And here in editing section, nothing. I have to just give a subnet that I will give as this one. Okay, the available zone USFN East FN 1A, and select your group, second group. So I will go with the default second group, right? And what I will do, anything else is required. That's all. So Ubuntu is fine. And then like I will go with the launch instance. Okay, now come down here and you just say view install. Let the server comes up. Okay, it has come up. So what I will do that, I will go to my folder where you have a put.exe. I'll just launch the put.exe. Now what I will do that, I will just try to copy the public IP. Copy the public IP, go over to this, and I'll just create. So as you know that this is a Ubuntu server, I have to always log in as Ubuntu. But what I can do that, I don't want to do this now as of now. What I will do that, let me create one session actually. A session. What is that? Say for example, Rajesh, every time I need not to really do it actually. We give and do all the settings. I should have some kind of a saved session. Using that only, I can able to log in it without any problem issue. So how to do that? So let me create it, because we know that most of the time we'll be using Ubuntu server as our we will be selecting Ubuntu as our Linux. Sometime we'll also select the CentOS also. Sometime we'll select even the Amazon also. Anything it could be. So whenever you're selecting a Ubuntu as your AMI image, then by default what happened that you have to log in as a Ubuntu user, right? Whenever you try to launch through PuTTY, you have to always log in as Ubuntu. Same thing if I'm choosing Red Hat or CentOS, the username is this EC2 user. CentOS, it is CentOS only. For whereas a Red Hat or else for our Amazon Linux, always the normal login is I've always EC2 user. This is the user name with which we will log in it always. This is the default user. For the Ubuntu, always it is Ubuntu. Let me do things since I'm following the Ubuntu only. Let me just say Ubuntu at the rate, and he'll also give the same thing, Ubuntu at the rate. Right. And then what happened, right? I'm going to set some session here. So this session is okay. Terminal, nothing is there. Keyboard, nothing. Bell, you can off it. Features, is there anything is required? No. Window 24, this is big. Appearance, let me change it and let me give 16 and let me save it. Anything else is required? Color, yeah, color, let me give a foreground color, right? And a connection, let it be 300. And here SSH, expand auth, you expand it. Credential, give this Jenkins.ppk file. So these are certain settings which you have did for this Ubuntu at the rate. What you have to do that, you have to just save it. So with whatever you did the settings, you created a session with the name something Ubuntu at the rate. It has all those settings, whatever I did till now. Now what I will do that, I have saved it. I'll just cancel it. Again, next time when I try to log in it, what I will do that, first let me copy this public IP. And then I will go to my folder where I have put exe. Just try to click on this and say load. It has loaded. Just give your IP address. That's all. Copy it and just open it. Right? Accept it. It will log in. Right? So this is a simple way. From next time onwards, what I will do that I've just used that session and I'll just directly give an IP address and I will log in. Right? I know to again do a setting again. So in our upcoming sessions, I'll be using mobile XTerm as well as a super PT also I will use it, or super PT I'll use it to log in to make sure that we will be logging at a very faster pace. Now what I will do, guys, actually that we know that as per our diagram, if you see this diagram, where is it? Yeah, not this one. We have this one dependencies, right? We have a, if you suppose I have a Python for dependencies, how I can resolve with the help of a pip actually. So shall we install the pip here? Yes, we'll install the pip here. So let me check whether the Python is there or not. I think Python is there, but the Python 3 version is installed. So if it's a Python -3 version, you see that Python is already installed in my system. I need not to really install it again. So whenever you're installing a Python 3, you need to even have a pip3 to be installed actually. You have to install the pip3 also. So to install the pip3, I don't know the instruction. Let me Google installing the pip3 on in Ubuntu something. So I can go with any site. Let me go with this site and check what is the instruction is given. Let me even open this site also. I can compare with the two sites. Okay, go over here. Okay, let me say what he says that actually. He said that whenever you want to install the pip, actually you have to say Python 3 pip. Okay, let me check that also. Pip 3 version. Okay, installing pip for Python 2. Not for Python 2. Python 3 is only required. Yeah. Right.
So
So
there is
yeah.
another way to install pip. You just search by get pip something in the web browser. That will give you a Python
Yeah.
script. So that you can easily
Yes.
install.
Yeah, I can do anyways. No issues. Yes, sudo apt update, and then there are many ways are there, sir. So I'll install this. Okay, so let me clear it. Let me try to. Now, the thing is that actually, as I said earlier, right, whenever you need a Django framework to be installed, right, in your system, you can, with the help of a pip, you can install the Django framework, right? Because pip will try to install or download any kind of a dependencies where your Python is needed. So if the Python, with the help of Python, you are developing the web framework, then you need to install the Django framework actually. So how we are going to do that? If I say pip-fn version, I think pip is installed. Yeah, pip is installed actually. So then what will you do that? You will just say pip install Django. Django, right? Okay. Oh, it says that actually, okay, this is, you need to create an external environment, manage environment, you have to create it. So before you try to do it, you cannot directly run that. You need to create an some external management. He said that external managed environment, you have to create it. Okay, I'll just go with the installing Django using pip3.
Can you use pip3 and
Yeah.
save one?
Yeah, pip3 or yeah, or else activate. I don't know. Let's see. Pip3 is there, right? Pip3 Python and pip3 introduction. Then he said that you need to create this virtual environment or VN, we say, right? And then he's installing Python pip3, which pip3, and is not given here. Python m-m. Earlier it was simple, guys. Now they have did little changes here in installation. Not this one. I might go with some other installing Django using pip actually. Yeah. Let me check this one if he has given a documentation. Not this one, sorry. We'll say pip3 is there. Huh? I think pip3 correct, but pip3 install Django, it will not directly do that actually. As per it will throw the same error. So what you have to do means you have to create some environment actually, and you have to activate it. How to do that? Stack Overflow, we'll see. Even I don't remember long back I used to. Yeah, this is what you have to do actually. Yeah. Python 3-m. This is what you have to do it. Failing. Okay. App install. No. No, this is not the way actually. No. You have to run a sudo command. Failed to do it actually. After installing the pip3, you need to install the, after installing Python 3 env package, recreate your virtual environment. Oh man, he's saying something to install this.
Sir, can you see that ensure pip is not available that in the first line?
Pip is, what is it?
Can you read this? The virtual environment was not created successfully because ensure pip is not available. Can you try to install ensure pip?
Install pip you're saying, huh?
Yes. Can
Pip
you
is
read
already there, no?
ensure pip? Ensure ENSUREPIP.
Where is it actually? Can you tell me?
Can you read that line? The first line.
The word was not created because ensure pip is not available. Ensure pip is not available. So you need to install the Python 3-e package. Okay. This is certain new things which they have added in Python 3 actually. Earlier in the Python 2, it was simple actually. Yeah. So after that, let me run this command. Yeah, I think it has created that env. After that, what it says that actually that you have to activate it actually. Yeah. And then like you can install Django. Like the it. Yeah, now it is installing Django. You could see that it is installing the Django, but again, Django is internal depend upon the ASC, egg, ASGI ref, and also it is depend upon the SQL parts. So all these things are getting installed, guys. So what I'm saying that actually with the help of a pip, actually you'll be able to resolve any kind of a dependencies for your Python, right? So the pip might need many of the other package also. Like for example, if I do a pip freeze greater than uh, what is it requirement.txt file. So it will create a file. You could see that actually it will show you these are all the dependencies, whatever it needs, right? It needs a Django 5.1.1, SQL 5.0.5. This is the version it needs. So it will resolve it actually. It will try to download all this requirement. Right? Is it clear? Yeah, correct, Sandeep. Yeah. Python -m pip installing env. Yeah, that's true. So similarly, like there are many things are there, guys. For example, like whenever you want to develop any kind of a front-end application, use the React.js actually, right? And for the React.js, basically what happened that you need to install the Node.js actually. So you can try out this when you do a Node.js installation on Ubuntu. What happened, right? You're going to get some commands. Like for example, you're going to get a npm npx, like that. You will get all those commands if you're installing the Node.js on your Ubuntu. So whenever you want to design the React.js, then the Node.js should be there actually. So the node should be there. So when you are installing a Node.js in your Linux machine or in your Ubuntu machine, as part of the installation, you will get even this commands also npm npx actually. Right now, I will not be showing that. I will be just explaining you what exactly it does actually. Now, what is happening is that actually, guys, you after installation, you will get this command. Then I think you need to create some folder. Say, for example, I think something. I'll just say, oh, sorry. Uh, and then go to your right. So what you need it actually that you basically after installing it, all your this one, you will basically get Node.js installed as part of this. If you execute node-v, right, then what will happen that you will get that command. So this is to verify whether the Node.js is installed or not, right? Then what you will do that you will try to create a very simple React.js, application you're going to build with the help of an npx command. So what is it? You just run like this, something like this. Npx, what is it? Create -react -app and say my app. Now, right now it will not run because Node.js itself is not installed. So how it will run? So you have to either you can install this package and run it. So what it will do that this is going to create a simple React application with the name something like my app. So now what happened? What I'm trying to tell that actually for the Node.js and all, right? For the Node.js application and all, whenever it needs any kind of dependencies, you can install through the npx or npm. So npm and npx are the tool which are used for resolving any dependency for your Node.js application. So Node.js means you can either build your React.js or JavaScript or else AngularJS, any kind of a front-end based you need to resolve means you have to always install the Node.js. So Node.js will have these two commands. With these two commands, you can install any dependency. It will resolve it. Right. So like this, we have to understand. Now, in our case, we are working on the Java-based application. Java's dependency, everything will be resolved by the Maven itself. We need not to worry. Maven is a build tool as well as it itself will also resolve the dependencies also. So we will be seeing in some time how exactly we can build how we can install all kind of dependencies with the help of a Maven. And Maven has an important configuration file by name pom.xml. in that pom.xml only, we will be mentioning all kind of a dependency, all dependency information, information, as well as all plugin information, all the things we will be writing in this pom.xml file. This is one of the standard file which would be written. Again, the question comes, who will be writing this pom.xml? The developer itself will be writing the pom.xml file. Developer only will be writing. So then in that case, Rajesh, do you have to edit this pom.xml for our requirement? Yes, we need to edit it. He will, by default, he will give his the pom.xml file along with the source code of your Java application. But what happened, based on the requirement, what you will go and you will edit it and you will save it, and then like you will run the manual build too. Is it fine, guys? Okay. So now, as part of this, what we have understood with this diagram, what we are understanding is that actually that, right? So whenever you are building any application, first the thing is that you need to, code will be pulled from Git through the Jenkins, right? Then from the code, you need to build the package, right? That's what the build curve will do. Third, what happened? Even so, what happened, right? After that, what happened, right? As a part of building the application, what the developer will do, developer will also write a unit test cases. What developer will do? Developer will write a unit test case. Even that unit case, even the unit cases also will be written by the developer only. So what the unit test case will do, that unit test case is going to test the code. Whatever the developer has written the code, right? It's going to verify the the functionality of that application, whether whatever the code the developer has written, whether that is a proper or not. So for that, what happened? The developer himself has written a code which they call as a unit test codes actually. Even that unit test code has to get executed, and that unit test code should be passed. If it is passed, or if the result is passed, it means that it is success. It means that whatever the code they have written is fine. If the unit test case itself will fail, it means that the code itself is not correct. So you will reject that build, or you're going to reject that code, and you're going to tell to the developer to rework on it because the unit test case results is failed state. Right. So what we have to learn and understand is that actually we have to even understand that how exactly this unit test cases works. Okay. And every developer, right, whenever they develop the code, they will even write a unit test case for it also. Right. So is there any tool which will run this unit test cases and give the result? Yes, there are some tools are there. Right. It is a language specific tools. So you need a unit test tools also is required, that we call it as a harness tool. So what will do that tool is going to run the unit test cases, and then what happened, right? It is going to give you the result either passed or failed, like that, right? So even what happened, right? So what happened, right? Like the developer writes the unit test. It will, so what the unit test will do, it will test the basic functionality. It will test the basic functionality of the code. After the unit tests is executed, the result, either it's a pass or is shared to the developer. So this is what will happen when you're trying to do a build process actually. It means that you need to pull the code from the Git, and then like you need to, from the code, you need to build a package out of it. And after building the package, what are the unit test case which has been written, even that should also get built, and it has to get executed. And after the execution, what are the result you get? Either it pass or fail, you need to give that result to the end, the same developer. Right? So as I said, guys, even these unit test cases, even this unit tests are written by developer only. Say for example, if a developer has chosen a Java language to write a Java program, after that he will be writing a unit test actually. That unit test also will be written in the Java language only. Same thing if the developer is using a C language to write a program or to write a project, he will be writing a unit test cases test, which is again written in the C language only. So whichever language. So what this unit test will do, the unit test will test the code itself. Whatever the developer has written the code, right? The Java application or Java code, it will test it. What it's going to test it is going to test whether the application, whatever the developer has written, whether it is meeting all kind of standards. So what are those standards? What it actually look into it? It's going to do a code check. It is going to check whether how much the code coverage is happening. Say, for example, if the developer has written some 100 lines of code, has been written, and your unit test cases, okay, it is only checking or it's only verifying. It is only verifying 50 lines of code. Means your unit test. Then what happened? We will consider that as a failure. So we will consider it as a failure. Suppose, for example, the same 100 lines of code is there, and your unit test is actually verifying some 95 lines of code. Then we will say that the unit test is passed actually. So usually, what is happening that in case of your in the industry, what will happen that all your unit tests should be passed actually. The unit test can be one program, it could be 100 program. All the 100 unit tests should get passed actually. Once it is getting passed, then only we will say that actually whatever the code the developer has written is correct actually. Right? Right, it is correct, and we'll accept that build and we will proceed it further. It means that we'll accept that build. We are going to we are going to deploy that build into our target environment, and then we will do further testing, whatever we want to do it. Right. So if the compiling is done, if the build is success, but the unit tests are failed, we will not consider that as a build. Actually, we will reject that build and we will tell the developer to do a rework. Is it fine, guys? So for that, what happened now? For that, for your unit tests actually, right? So let us talk something about unit test, and then we will wind up the class today's session, right? So this is nothing but the unit testing. So what the unit test will do, as I said, right? That unit testing. What does the unit testing mean? It will test the code. It will test the code. It is a code. So what is it? It is a code. So unit test again, it's a code. It's a code written. Unit test is not, but it's a code written to test the application code itself. So which we call it as a unit testing. Okay, and also we call it as a white box testing. So usually a developer will say it as a white box testing. Right? Not white box testing. WIT, white box testing. White box testing. Okay. Now, as part of this execution, guys, what you are going to get? You are going to get the report actually. So you're going to get the report. So what report you are going to get? Whether the report is passed or failed. Like this, you're going to get the report. Pass or fail. If it is pass, okay, no problem. It is looking good. If it fails, you are going to report that issue to the, either it is a pass or fail, you have to report that report to the developer actually. Right. And apart from this, actually, guys, apart from this unit test, there is something which we call as a code coverage, which I'll be discussing in our next session, not now, right? Code coverage. So what is a code coverage means? So what exactly code coverage means? Code coverage is something like where it will check the percent of your code checked. So how we say that? It is nothing but it is a percentage of the code covered. It's a percentage percentage of code touched, or we can call it as a tested, you can say, from unit test. Okay, usually what happens, every organization, they keep some standard of this code coverage. Most of the organizations, they'll keep it as 90% of the code should be covered as part of execution of unit test. If it is less than 90, say for example, if it is covering 89% of the code coverage, okay, if it is covering 89%, still you will reject that build. You'll say that, okay, it is not meeting the standard. It means that it is not covering up to 90%. So many of the organizations, they'll keep as a 90% of the code coverage, 90% of code coverage. But many other companies are there where they strictly follow to keep up to 95%. Some of the organizations are there, like for example, Walmart, Amazon, they said they'll not compromise. They'll say that your code coverage should be up to 95%. If it is not meeting 95%, if it is meeting 94.99999%, they will say that, okay, reject that build. We are not reject that build. So it has to meet the 95% code coverage, right? So this is something which we will be understanding in our next session. We have to understand about that also. Some of the questions will come across from this also. So code coverage, what happened, right? Right, code coverage will be dealing separately, guys. Don't worry. Right now, as I said earlier, right, to test all these unit tests, actually, there are some harness tools are there. There are tools are there. We call it test harness tools. Actually, we have a test harness tool. Test harness tools which are available. We will be using that tools to do a unit tests actually. So what are those tools? Again, it is a language specific. Say for example, if you're having a Java language, right, there is a tool by name JUnit actually. There is a tool by name JUnit which is used to do a unit testing. So this is a tool which is actually used for running a unit test cases, unit, right? Similarly, what happened, right? You have a Python actually. For the Python language, right, there is a harness tool by name PyTest. What is it? PyTest. PyTest is a tool or the unit tool which is used for testing your unit test cases actually. Same thing for your .NET application or .NET language. You have something known as a NUnit actually. What is it? For your .NET, you have a harness tool known as NUnit. Similarly, for example, assume that you have a JavaScript actually, or the Node.js or JavaScript. So we have some two important tools are there, which is nothing but your Jasmine and Mocha. There's a unit test tools by name Jasmine and Mocha, M-O-C-H-A, Mocha. Right, guys? So we have to understand about this harness tool also. Not that much, not in very in depth, but just like in a very high level, we have to understand it. Right? Right? Because all these unit tests and all, right, this will be used by the developers only. We will not be using it, but developers will be using all these tools. But anyhow, we have to know about this, how it works internally. So in the next session, what we will do that, we will be trying to understand about what exactly this code coverage is all about, right? And what are these harness tools and all. And we'll take an example of Python. Say, for example, for Python, we have something like a PyTest. We will install the PyTest and we will write a simple Python program, and we will going to check it out how PyTest will work actually. Right. Apart from this, you have something a static code analysis tool is also there, which we have to discuss. I think I'll not be able to discuss it now. We'll be discussing about that. There is something as a static code analysis tool. So we will be continuing our discussion with these things in the next session. Static code analysis. Right. Okay, so guys, what is our next topic is that actually we will be continuing from here onwards. Like we need to understand about the unit test. So next session, we will be understanding about the unit test, what exactly unit test is all about. And in some more details we'll go, and we'll go through a harness tool, understand about what is this harness tool. We'll take an example of this PyTest, which used as a harness tool for your Python application. And we'll also discuss something about the static code analysis. Code analysis. So what it will do that, the static code analysis tool is going to check the, or it's going to check the code quality. It's going to check the code quality. It means that you need to maintain some standards, right? Whenever a developer writes an application, there's some standards are maintained. So what your static code analysis will do that, it is going to do a, it's going to check the code quality, and it provides a report to you. It means that basically it's going to there are some benchmarks are there which you need to set it up whenever where your code is undergoing under static code analysis, static code checking. And it has to, there has to be some benchmark has to be set. If it is if the benchmarks, whatever the benchmarks which I've set, right, if it works, I mean, it means that if it get passed to the or through the benchmarks, then we will say that when we certify saying that our code is proper. It means that the developer, whatever the code is written, right, it is, everything is clear. Or else what is happening, right? Sometime what happened, right? You will going to set something like a quality gates we sets actually. So we can have something as a quality gates. So we will even see that also later, not now. So there is something like a quality. This is optional, guys. It is not really required. But many of the companies have started setting up the quality gate checks. This is also one of the interview questions. Sometimes they will ask you quality gate checks. So here what happened, right? You're going to set up all kind of a quality gate checks. If the quality gate check is getting passed, then only you will certify that the code is correct. If it fails, then you will say that, okay, you will reject that code, or it means that you will reject that build. So what is the static code analysis, quality code checks and all, we have to see in our next session, not now. Right? So then this one. Is it fine, guys? So with that, we are going to stop it today's session. We will continue from Monday onwards. Is it fine? So sounds interesting, guys.
Yeah, okay, sir.
Yes, sir.
So I know it was more like theoretical today, because like I thought like, let me cover up this, what is build and packaging. Then only we will be able to understand how the Maven works. So that's what I explained about this dependency, right? I know, and gave some few examples. And then like we need to understand about something about the unit testing, something about the static code analysis, because all these are the part of your pipeline only. See, when you are trying to write a pipeline, you will integrate many other tools also. Like for example, your SonarQube will integrate, right? You will integrate your test harness tool also, you will integrate. Suppose you want to perform some load and performance testing, you want to do it at the same time, you can even integrate with your JMeter tool, right? There are so many tools which comes in as a part of the pipeline. So you need to integrate that tool, and you need to call, and based on the based on the report, whatever you get right, you're going to take a further action on that. Right? If the report is failed, you will not proceed with the pipeline. You're going to just stop executing the pipeline further, right? And you will get the email saying that it has the static code analysis report has been failed, hence the pipeline has been stopped actually. If it is getting passed, then what happens? You will allow it to proceed to further, and you can do a further operation of the pipeline, whatever you have written. Say, for example, you want to go and deploy into the test environment. In that pipeline you have written, it will go and it will deploy it actually. And then like post deployment, if there is any kind of a sanity test case has to be get executed as part of the pipeline, or you're going to call the sanity test case also like that. So like that, you will be whatever the steps you have written, based on certain actions, it will proceed further. If some actions are getting failed, you're going to stop there. So we will be seeing all those things in our when you're writing a pipeline. Okay, fine, guys. With that, we'll stop it now, and we'll meet it on Monday again. Right? Let me stop the recording.